Lately, I've been talking about building high-frequency assemblies. I often hear the question about which way of adjusting the contours is most convenient for an amateur experimenter. There are two easy ways to do it. They are either changing the capacitance or the inductance of the contour. When working with high frequencies, we often change these parameters simultaneously. An example of such simultaneous adjustment is moving rotors of a frame variometer. The former consists of two open-ended copper rings that can be moved with the help of a contour handle. The closer they are to each other, the higher are the inductance and the capacitance. Moving the rings apart has the opposite effect. In order for the whole structure to work, the axes of the frames should be made of high-quality dielectric. However, this design has a drawback. There is a quadratic decrease in quality at lower frequencies. The opposite is true for the high frequencies. The other variant of making adjustments in high-frequency contour is moving the contact over a coil made of a back conductor. A contour of high-powered frequency can have a frame with a moving segment. It can consist, for instance, of metal rods with a link. When using this assembly, you should make adjustments of inductance rather than of frequency. Otherwise, you may get a high-frequency burn. And finally, the third method of making adjustments uses a linear differential variable capacitor. It has an unusual design. The rotor moves over two linear stators. They solve the problem of moving contact in a device. So these are the designs of self-made adjustment assemblies for high frequencies in brief. Next time, we'll talk about them in more detail.